Introduction. Do you all know that the organic food that we all eat contains carbon? Carbon? But teacher, isn't that bad as it contaminates our food? No, Ramesh. In fact, carbon has nothing to do with the pesticides and chemicals. Carbon makes our food healthier. That is why carbon is a very important element in our day-to-day life. Children, in this lesson, you will learn about carbon, the versatile nature of carbon, the chemical properties of carbon, and a few important carbon compounds. Objectives. At the end of this lesson, you'll be able to identify the covalent bond in carbon, explain the versatile nature of carbon, describe the chemical properties of carbon compounds, describe important carbon components. Bonding in carbon. The covalent bond. Carbon is the chemical element with symbol C and atomic number 6. As a member of group 14 on the periodic table, it is non-metallic with 4 electrons available to form covalent chemical bonds. A carbon-carbon bond is a covalent bond between 2 carbon atoms. The most common form is the single bond, a bond composed of 2 electrons, one from each of the 2 atoms. Carbon also has the unique characteristic to form long chains of its own atoms. This property is called catenation. The allotropes of carbon are graphite, diamond, and amorphous carbon. Versatile nature of carbon. Organic compounds are made up of carbon, hydrogen, oxygen, and a few other elements. The unique nature of the carbon atom and the arrangement of the bond carbon forms with other atoms enable formation of organic compounds. Tetravalency. Carbon is tetravalent in nature. It always forms covalent bonds by sharing electrons with 1, 2, 3, or 4 carbon atoms or atoms of other elements or groups of atoms. Strong carbon-carbon covalent bonds. Carbon atoms form a strong bond resulting in the formation of stable compounds. Carbon atoms can also form stable bonds with other atoms. Carbon-carbon multiple bonds. A carbon atom can also form multiple bonds as it is small in size. Double and triple bonds can also be formed with not only carbon, but with atoms of other elements like oxygen, nitrogen, and so on. These multiple bonds provide a variety in the carbon compounds. Saturated and unsaturated carbon compounds. Carbon forms many compounds. The 2 main types of compounds are saturated compounds and unsaturated compounds. Saturated compounds. The carbon and hydrogen compounds, where the adjacent carbon atoms contain only one single covalent bond, are known as saturated hydrocarbons. The reason for the formation of saturated hydrocarbons is because all the 4 bonds of carbon are fully utilized and no more hydrogen or other atoms can be attached to it. These are known as alkanes. Unsaturated compounds. Compounds of carbon and hydrogen that contain double or triple covalent bonds between the carbon atoms are called unsaturated hydrocarbons. These are formed as all the bonds of carbon are not fully utilized by hydrogen atoms, and more of these bonds can be attached to them. Double covalent bond unsaturated hydrocarbons are known as alkenes, and triple covalent bond unsaturated hydrocarbons are known as alkynes. Chains, branches, and rings. Many compounds contain carbon atoms and are linked with each other. The chains of carbon atoms are linear chains, branched chains, and cyclic rings. Linear chains. Tetravalency and catenation of carbon compounds allows the formation of stable chains of atoms with different chain lengths and structures. Branched chains. Carbon compounds can be branched when the carbon atoms are more than 3. Branched chains give rise to a different structure to the parent alkane. Cyclic rings. Carbon rings are rings of carbon atoms. The number of atoms to form a ring is 5 and 6 carbons. Rings of 3 and 4 are possible, however, they have a larger ring strain and are unstable. Carbon, a friend in disguise. Carbon is a friendly element. It not only bonds with hydrogen, but also with other elements such as halogens, oxygen, nitrogen, and sulfur. The compounds are formed in the same manner as with hydrogen. However, instead of hydrogen, the other elements is used, and this element replacing hydrogen is called a heteroatom. A functional group is created that confers specific properties to the compound without considering the length and nature of the carbon chain. Homologous series. Homologous series is a series of related chemical compounds that have the same functional group. These differ in formula by a fixed group of atoms. The successive members of such series are called homologous. Even though the general formula remains constant in a homologous series, specific members of the series may have different structures and properties. However, the reactivity usually remains the same. In any homologous series, a gradation in the physical properties is observed. This gradation occurs due to the increase in the melting points and boiling points along with increasing molecular mass of the compound. Nomenclature of carbon compounds. The system of assigning a proper name to a particular carbon compound is called nomenclature. Most carbon compounds have 2 types of names. Trivial names. Trivial names are the commonly used names of carbon compounds. These are derived mostly from the source of the compound. However, names formed using this manner is ambiguous and repeating. IUPAC names. Carbon compounds now need to be named in a more systematic way. A committee called the International Union for Pure and Applied Chemistry, IUPAC, put forward a system of giving scientific names to carbon-based compounds. These names followed all over the world and are called IUPAC names. Chemical properties of carbon compounds. Carbon is a very reactive element. Main chemical properties are listed. Combustion. The burning of a substance is called combustion. It is a process that generates a lot of heat. When carbon and its compounds are burnt, heat energy, carbon dioxide, and water are produced. Oxidation. Oxidation is a process where carbon compounds are easily oxidized after combustion. After complete oxidation, additionally, we have reactions in which carboxylic acids are generated through alcohols. Addition reaction. Hydrogen is added to unsaturated hydrocarbons in the presence of catalysts and produce saturated hydrocarbons. These catalysts are substances that cause a reaction to occur or proceed at a different rate without affecting the reaction itself. Substitution reaction. Most reagents are not able to generate any reaction from saturated hydrocarbons. Hence, these saturated hydrocarbons are inert. However, in sunlight, chlorine gets added to hydrocarbons. Since chlorine replaces the hydrogen atoms one by one, it is called a substitution reaction. Ethanol and ethanoic acid. Ethanol. Ethanol is commonly known as alcohol and is liquid at room temperature. It is an active ingredient of all alcoholic drinks. It is a good solvent and hence is used in medicines. Consuming small quantities of dilute ethanol leads to drunkenness, but intake of a small quantity of pure ethanol can lead to death. Ethanoic acid. Ethanoic acid is commonly known as acetic acid. It is a part of the carboxylic acids group. When 5 to 8% solution of acetic acid is mixed in water, it forms a substance called vinegar. The melting point of pure ethanoic acid is 290 Kelvin. Because of this property, it freezes during winter and hence is also known as glacial acetic acid. Carboxylic acids are characterized by special acidity. However, as carboxylic acids are not ionized, they are weak acids. Soaps and detergents. Soaps and detergents are used in our daily life to wash clothes, clean hands, clean utensils, etc. The substances that form soap are sodium or potassium salts with long chains of carboxylic acids. The soap molecules form a separate structure called micelles. A micelle is formed when a variety of molecules, including soaps and detergents, are added to water. These molecules must have a strong polar head and a non-polar hydrocarbon chain tail. When you add this molecule to water, the non-polar tails of the molecules clump into the center of a ball. This is because they are hydrophobic or water-hating. The polar head of the molecule interacts with the water molecules on the outside of the micelle. Did you know? Artificially manufactured hydrocarbons are called trans. Our body lacks the enzymes to properly break down the trans compounds. That is why trans fats are dangerous and unhealthy, as they tend to build up. Carbon is the fourth most abundant chemical element in the universe by mass after hydrogen, helium, and oxygen. Carbon is abundant in the sun, stars, comets, and in the atmospheres of most planets. Summary. Let us summarize what we have learned. Carbon is a non-metallic substance with 4 electrons and helps in forming covalent bonds. The versatile nature of carbon can be summarized with tetravalency, strong carbon-carbon covalent bonds, and carbon-carbon multiple bonds. The chains of carbon atoms are linear chains, branched chains, and cyclic rings. Carbon is a friendly element that bonds with other elements. Homologous series is a series of related chemical compounds that have the same functional group. The system of assigning a proper name to a particular carbon compound is called nomenclature. The chemical properties of carbon are combustion, oxidation, addition reaction, and substitution reaction.